All right, hi there. Um, we are doing video notes for Learning Target 1.5, Parent Functions and Transformations. Again, we're using these video notes if we're absent, on vacation, sometimes just when we need a little review. So let's move to the notes right away. We know we don't do the warm-up for the video notes. That's an in-class thing. So identifying function families, that's our first part. So functions that belong to the same family, we call it, they will share some key characteristics. So we're going to be using this chart below to learn those key characteristics. The parent functions, so I'm going to put a box around it, very important, are the most basic function in the family, meaning they're short and sweet of it. There's certain things to look for in a parent function, and we'll go over that. And then the transformation ones, functions in the same family, are then transformed or transformations of the parent functions. Okay, so the first one, here's our functions. This is our family. We're going to look at what the rule looks like, the graph, the domain, and the range. Okay, so if we look at this first one, a linear equation, the important part is we look at, it's just going to be f of x equals, and then we're going to have some x there. There's going to be no exponents at all. There can be numbers after it, but the parent one looks like this, and then it's just a basic linear equation. It has to form a line. The next one is our absolute value function. So the key is you will be seeing the absolute value symbols. That will tell you it's an absolute value function. And then again, it's going to look like this V. I think you learned about those in algebra. And same with quadratics. Quadratics, the parent function, is f of x again. So this is where we now have an x squared. Quadratics always will see the little squared, and then it kind of looks like a U shape here, right? It can go up or down. It could be sideways as well. All right, next we have the function, a cubic function. That's where we see the 3, right? And the graph kind of looks like this. It goes one way and then it switches and goes the other. That's a cubic one. And then we have our radical numbers. Or I'm sorry, our radical functions. And that looks like you have the radicand symbol, right? That square root. That is what's called the radicand, so we call it the radical function. Whenever you see that, even if there's other stuff in it, the parent function is right here. So we're going to be using this chart to refer back to and just look at some key things. So if it has absolute value, it's absolute value. If it has a little 2, it's a quadratic. If it has the radicand, it's a radical, and so on. So that's the first part. Let's go to example 1. I can identify the parent function to which a function belongs. So we have one here, so k of x. So basically, I'm going to look through it and see if I see anything that stands out in our parent functions. We aren't given graphs, we're just given the functions. I notice right here, there is a 3. That little 3 tells me it has to be cubic. So this one is cubic, or we would say the letter D. I'm going to cross that out because I used it. It's that simple. So then looking at this other one, m of x, so now I'm just looking at 5x plus 2. So again, when we look at the parent function, we have an x with no exponent. So I'm looking through and I see linear, right? Remember linear? It has an x with no exponent. So the parent function for this one. So this is actually a linear. Letter A. I'm going to cross that out. Next, I go through g of x, and I have this whole long thing. And in all of that, I notice the little 2 exponent. That tells me right away, the little 2 tells me it's a quadratic function. That's the parent function, so the most basic one, so it's a quadratic. And that is the letter C. Cross out. The next one, P of x equals, and those straight bars, remember, those mean absolute value, so that matches right up here. I see absolute value signs. That's the type of function, parent function we're going with. So the type would be is an absolute value, and I like to abbreviate that one. That is B. And then the last one, it says it's going to be radical, but let's just check to make sure. So do I see the radican symbol in this one? I do. I see it right here. So this is automatically a radical. And that is letter E. So that's the most basic part of this, is looking at the parent functions and then giving some transformations of them and identifying which type it is. All right, so down here is a little chart. I gave you a big piece of paper, front and back. It's the 1.2 visuals. That's what we're going to be referring to when we look at these. I made them a little bigger, and then I also gave you another chart. So when you look at your notes, you should print off. I have these in color when you print them. Here's the chart that's bigger on there. This one's a little bigger so you can see what it means. And then I added this chart, which I really, really like, this one, and then the one on the back of your paper I use the most. So I'm going to call this one, this is my favorite. I'm going to put a star on it, and I'm going to put fave for me, and that's the one I'm really going to use a lot. And then I'm also going to use on the back of it, I marked mine up a little bit, and yours should be too, because we would have done this in class. Or you can pause the video and mark it up too on your note sheet. This is my second favorite, only because it has everything. We'll still be using this, but when we get to our last examples, we're going to learn how to change the domain and range, and that tells us what to do. So we'll be using that for the graphs part. While the front part of the chart is just like that other fave I had on the front of the page. So we're going to use both of these. So let's turn the page to the second part of our notes, and we're going to look at identifying the parent function and then describing the transformation of a function. This is where this chart is going to come in handy. So, I'm going to use this first one on the first page here, because remember, a horizontal shift, that is, we use the word translate with shift. It's good. We're going to use the same thing. So just remember, we're going to be using the correct terminology. Instead of saying shift, we will be saying it translates. That's for the up and down and left to right. It just sounds better, and then when you go to take tests and stuff like that, it's going to make a lot more sense. All right, so this is the one we're looking at on the side. Make sure you have that out to the side. And then I'm going to show the notes section and then just kind of where I refer to it. So the easy part is we're going to use the front of our note page to identify the parent function. This is just like what we did. So going through right away, I notice on this one, I can write the parent function. There's a little 2, which means if we go back to our front notes page, which one's the parent function has the little, it's squared, little 2 right here. So it's f of x equals x squared. That's all we do for the parent function. So f of x equals x squared. Okay? That is what we're going to do when we write the parent function. Just use that chart on the front. The next part, we have to figure out what is being done here. So we're going to be looking at the examples to see what's happening. So right away, I notice something is being multiplied out front. I'm going to circle that, because that in my chart, I'm going to look for something that's multiplied out front. So going back to my chart, if you look at this, I'm using this bottom one, and I'm looking at, so we have f of, and then we have something in parentheses. So I know it's not this, f of x, and then we don't have plus a number yet. We're looking at that. I'm just going through this one. When we reflect, it's just a negative out front. So now I go here. This one has a number. This is what we multiply out front. That's when there's a number out front. It's actually, we call, if the number is a whole number, it's called a stretch. And then if it's a fraction that we multiply by, it's called a compression, or you make it smaller. It's a type of dilation. But this is where, when we have a number multiplied out front, this is where I'm going to look at what I do. So I'm just going to say whatever this number is, I'm going to say, because if it's a number bigger than 1, I'm going to say it stretches by that number. And just going back, I know it was a 2. So that 2 tells me, because we multiplied, I'm going to put it stretches by 2. Okay, and then the next part I need to look at is this -7. That -7 is all out by itself. Okay, it's not in any parentheses. So again, I'm going back to my chart, and I'm going to look at something that is just all by itself, not in parentheses, and we have minus a letter because it uses letters here. And I look through here, this is in parentheses, this is in parentheses. Oh, we have a plus something. I want a minus something. Oh, so I go down and I see a minus K. So that's where my -7 would fit in. So what's going to happen is we're going to go down whatever that number is. When it's outside of the parentheses and it's a minus something, that tells us we go down whatever that number is. So this one actually tells me I translate. And I'm going to put the arrow. You can put the word down. 7. And that's it. We found the parent function, and we took care of the 2 transformations. And that's all we do for these. We look through our chart and see kind of what fits best. Finding the parent function, again, that's the easiest because we can use the beginning chart to just find which one matches. And then we use the other charts to look through. So it's kind of like a scavenger hunt. All right, let's look at the next one. We have h of x equals negative times the square root of, everything here is underneath this symbol. So if it's all together, it can also have, you can think of it as having parentheses. You don't have to have them in there, but when we go to look for things, it's going to help. So the first thing I do is go to my front note page, and I'm going to find the parent function. This had a radicand. So I look for that symbol, and I find the parent function right here. F of x equals the square root of x. So that is f of x equals the square root of x. That's the parent, the most basic one. Got that part done. That part's pretty easy. Now we need to look at 2 things. 2 things are being done. So I'm going to circle, there's a negative out front. There's no number there either. It's just a negative symbol. So I'm going to go through my chart and see what that negative symbol means. So again, I like to use this chart, the bigger one on the bottom. And these are in parentheses, adding, subtracting. This is plus and minus. Oh, look right here. I have a negative out front of my f of x. So that tells me right away, I'm going to look over, see what's happening. And it says we reflect across the x-axis. That's the only type we're going to be doing for this section. So when there's a negative out front, just the negative, that's a reflection. We can say in the x-axis, about it, across it, however you want to word it. So for this one, so for the first one, I go back to my sheet, and I'm just going to write, it's a reflection. In x-axis. I write it this way just because I'm used to doing like 8th grade in algebra, and we used to say reflecting in, but again, the words about, the words across, the words over, it can all of those mean the same thing. So that was the first move. Now I notice underneath the radicand, so this whole entire radicand, if the +1 was out to the side, we'd be looking at where it's by itself. But it looks like since all of this is underneath, we have to think of this as one thing. So I'm looking at, that's why I put the parentheses in, since they're both under there, it comes as a pair. So I'm looking for something like x plus something in my chart. So I'm going to go to my chart, and right away I notice right here, oh, it's in parentheses. So it has to be this one, it's plus. So I put, there can be a square root, there can be a square or a cube symbol here too, sometimes, and sometimes there's not. But the important part is I'm noticing all this, since it's parentheses, that means all of it would be under a radicand. It's not the one that's out by itself, because everything underneath that radicand goes together. So we have to think of it as being in the parentheses when they're all under it together. So I'm looking at when I have x plus something, that means I am shifting, or I'm going to use the word translating left, whatever the number is. So I'm going to go back, and it looks like I am translating left. One. Because that number is 1. And that's it. All right, we're going to look at example C. Again, the first thing we need to do is find the parent function. So when I'm going through and looking at this, the transformation, I can see the cube, or the third power. So I have to go back to my chart. Some of you might have already memorized this, but my chart on the front of my note page, and I have to look at these graphs. I'm sorry, these equations, functions up here. Here is the third power, so that's a cubic one. So here's our parent function. It's f of x and then x to the third. That's the parent. F of x equals x to the third. Again, the most basic. So now we have to describe. This one actually has a couple things happening to it. So I need my chart. And we are going to look at what's happening to it. So I need this chart over here to the side so we can look at what's going on. So the very first thing I'm going to look at is right in here, I notice in parentheses, I have, this is like the last one we did. We get an x minus 2. It's all in parentheses. So I'm going to look in my chart for an x minus, and then obviously it gives us letters in here, but we have to look at what minus means. So I have in parentheses right here, x plus h, and oh, there is a 3 on ours, so that's why it has that little n there. And then we have x minus h. So we're looking at one with a minus sign in parentheses. So I'm going to go over here and say what it does. It shifts right, which means it translates right, whatever that number is. So I'm going to use the word, it translates. Again, it's going right. And then that number is 2. Okay, so we did that part first. And then the next part, out here, it's not in parentheses, it's just all by itself. We have a plus 5. So a plus 5 on its own. So let's go to the chart again and see if we can find something like that. So this first one, again, that's an x plus h. It's in parentheses. The second one is in parentheses, x minus. And then I have this f of x plus k. Oh, that's all by itself. It's out by itself. So that's the one I want because it's a plus something. So that tells us it shifts up, or the word we're going to use is it translates up whatever the number k is. So this one then translates up, and then my number for this one, it went up 5. And then that would be it for that one. So I just went and I picked out the pieces. I first found the parent function, but then I just went and I looked at what pieces were done to it. So with the parent, I don't worry about the x or the 3. Same with, I didn't worry about what's happening in the x and the radicand. You have to pick out the other things that are being done. So right now I want you to pause your video and I want you to type the checkpoint, just like the 3 that we did. So when you pause it and then unpause it, hopefully when we walk through, we'll get the same answers. Okay, so doing this one, for the first one, you should have had the parent function being f of x equals just x squared. We saw the square, so we put the square. And then your transformations, you should have got that we have this negative out front, so that means it's a reflection across x-axis. And then we have a plus 2 in parentheses. Remember, in parentheses, plus 2 means we translate to left, or left 2. And then the last part, we have a -1 all by itself over there. So that means we translate. And then when if it's out by itself, we're going to go down 1. So you should have came up with those 3. Any order, does not matter how you say it. All right, the next one. So this one we're looking at the parent function. If I notice, there's the radical symbol. So my parent is just f of x equals the square root of x. That's just the parent. So we have to see all the things that were done to it. So first of all, remember when I said if there's something under the radical, we put it in parentheses if there's more than one thing. These 2 things are underneath there by itself. So we're going to look out front first, where it's multiplied by 1/2. So looking at your chart, you would have noticed when you multiply 1/2, that's actually, we compress by 1/2. Okay? You could say by a factor of 1/2, but we could just say by 1/2. And then the next thing, I'm looking under the radicand, and I have an x minus 3 in parentheses. That has to go together. That's the in parentheses. So that when we have x minus inside of the parentheses, that means we translate right. And then whatever that number is, 3. And then the last part, we have this -5 all by itself. That's all by itself. So when I look at the -5 outside, that means we're translating down. And whatever that number is, so this was 5. So hopefully yours matched up with mine, even if they're in a different order. If not, maybe print yourself another blank sheet, look at the examples again, and give it a try. All right, so now we're moving on to the next example, example 3. I can identify the parent function and describe the transformation of a function from the parent. So this is when it's in written form. We're just going to be given it, so it's a little bit different than up here doing the work. This is just a sentence. So if our parent function is this, and it's translated to left, I'm going to go to my chart and look for to left. I have to look at the description over here. Left. Oh, right here. To left. That means I'm going to put x in parentheses, and it's going to be x plus 2. So right away, I know I'm going to have f of x, and then I'm just going to leave room. In parentheses, I'm going to do x plus 2. And because it was squared, that square has to stay on the outside of the parenthesis. It just pops in there. We don't do anything else with it. Same with the x. It stays there. These are the 2 part of the parent functions. We keep the x, we keep the little 2. We just put it on the outside. But putting it in parentheses and the plus 2, that's what tells us in parentheses, and the plus the number, that tells us we go left. So then the next part is 5 up. So let's look in the chart. Where do we see up? Shift up, k units. So, it looks like we have out on the outside all by itself, not in the parentheses, we're going to put plus whatever a number is that it goes up. So this one says it goes up 5. So after this, I'm going to put plus 5 just out to the side. And then it says reflected. We always reflect in the x. I know that means I need a negative out here. Your chart, when you look at reflection, remember, it's just a negative out front, just a negative symbol. There's no number with it. But then it also says it was stretched 3. So remember, when we stretch or compress, that's when we do have a number in front, out front. So since it's 3, it's a whole number. So it's negative and then 3. So the number goes after. So this would mean it's the reflected. This would mean it's the stretched. And then again, we have the in parentheses plus 2. That's the 2 units left. And the plus 5 is the 5 units up. So I just used the chart and my parent function, and then built all that stuff up. So I want you to pause the video and try the checkpoint for reading this, and here's your parent function here. Okay, so if you are looking at this, I'm going to go through it faster because you've already tried it. So my parent function here tells me I'm going to translate 4 to the right. So 4 to the right is going to mean that I am going to go in parentheses x minus 4, and then that little 3 stays on the outside, just like this top one we did. When it's x squared as the parent, the x and the square stay there. Sorry about that. And then the x and the square stay there. So then the next part is we're looking at 2 units down. So again, when we go up or down, that's out by itself, and down 2 would be the minus 2. And then we reflect it, which means we put that negative out front. It doesn't say compress or stretch, so there's no number. So we would put, this would be f of x equals, and then there is our translated function. All right, so now we are going to go to the very last part, which is the graphing, writing a function to describe a transformation on a graph, but then also performing translations on points as well. So they kind of go hand in hand since they all have to do with graphs. So the first thing we want to just make sure, we're going to use 0, 0 for the parent function as a reference. That's our parent functions. Those are our reference points. We're using the parent functions for these. And then we're going to describe what happens. Okay, so the very first one we're looking at is here we have a parent function. So the function family, this would be f of x equals, this would be the absolute value of x. That's just our parent function. Okay, function family just means what's the parent function. So then the next part we're going to look at is what was the transformation? What happened? So we're just dealing with 0, 0. So we just want to see what happened if I was at 0, 0. So I'm just going to use 1 point. I like to use where they meet on here. For this one, I'm going to use 0, 0 and see where it went to. So it looks like to me it went up 1. So if it went up 1, I'm going to look in my chart for those keywords, where it goes. I'm going to use this back chart now just because I'll be using for the domain and range. I'll want to use it. But again, I went up a certain amount. So that means that on the outside, not in parentheses, but on the outside, I'm going to put a plus 1. So that when I rewrite this function, it's going to be f of x equals the absolute value of x. And then again, it's going to be plus the 1 because if we go up, it's on the outside. Now, if we were to have gone left or right, we would put things in parentheses altogether. But because of the wording and how the chart shows us, we keep it outside of when we go up. Up means you just add something on the outside, and that's it. So this is also what we're going to look at. This is where we're talking about domain and range. So the x's are domain, the y's are our ranges. So this tells us what happens when you go up a certain amount of numbers for a transformation. This one says the x value stays the same, but you take y and you add whatever the number is you went up. So this is going to help us with this next part. So again, when we go up 1, so it says D, but we're going to say up 1, that means that the x value stays the same, but we're going to take our y and we're going to add 1 to it. So x stays, the domain, again, is our x's, and the range are our y's. So this becomes y, whatever the y is, plus 1. So meaning if I were to give you all the ordered pairs of the parent function, you would keep all the x's the same, and you would add 1 to all the y's, and then you'd replot the points, and you'd come up with the transformation. Okay, this will come in handy when we actually do points and it's not on a graph. All right, look at B. So again, finding the function family is easy. We can look at it on a graph. I see right away, this is my parent function. So f of x equals x squared. This is a quadratic. So f of x equals x squared. So again, now we need to see what happens. So as we can see from before, the writing portion up here, I like to always see if I go left or right first and then do up or down. So I'm going to do the same thing for here. So it said, remember, use the parent function. So use 0, 0 as your starting point, and then here's your ending point. They give you one here. So first I'm going to go left or right and see what happens. So it looks like I have to go left. 1, 2, 3. I'm going left 3. So I'm just going to write that over to the side. When I do left 3, and then I actually, from there, I'm going to go down 1, 2, 3, 4. And I'm going to go down 4. I'm just writing these as notes, so when I look at my little chart, okay, for clues, I'm going to see what it looks like, how I have to transform this. So I'm going to start with the left 3 and see what that looks like. So I'm looking for the words left, and we're going to use the number, this one we went 3, so we're going to be using the number 3 when we see the word left. So I'm going through here. This doesn't help much, but I'm going to use the words left, up or down, left. Here we go, left. This is what it looks like. So now I come over to here. When it's left, it has to go in parentheses. And remember I said there can be an exponent out here to the side. So I'm going to add that to the note sheet. It's not always in there, but it's assumed if there is an exponent like a 2 or a 3, it just always goes, you plop it on the outside. If it was on the X originally, you just put it on the outside of there. But we know that we went left 3, so we're going to do in parentheses X plus 3, and then we have to keep whatever our exponent is. So right away I have f of x equals, and then remember I want parentheses, x plus 3. That's what the chart told me to do. And then because the parent function started with that little 2, we have to keep the 2 on the outside. So we always keep these parts of the parent function exactly the same. Now we have to do, I'm going to put a little check mark because I found that in the chart, down 4. So now we have to do one more thing to this transformation function. If we're going down 4, again, I'm going to go in my chart and look at down 4, up, down. So down a certain number of units. So down, we're going to go down 4 instead of D. So I'm going to go over here and see, it looks like all out by itself. So on the back of it, I'm just going to put -4. Nowhere in parentheses, it's just going to go -4 on the outside. So I'm just going to put it back here, -4. It's not under the parentheses. It's still part of the problem, but that tells me I went down 4. So those were the things, those were the 2 moves I made. So I have to be careful here. For the domain part, I have to look at 2 things. I went left and down. So when I go left, if I'm at 0, 0 and I go, let's just go from one point, let's just go from what happens here. Left means, this is where this chart comes. So if I go left, that means I'm going to take whatever my x is and minus that number. So I went left 3. So I have to take my x and -3 from it. That's my domain. That's my x's. That tells me what to do here. And then my down 4 part, let's look at where I found down 4. This is, I'm looking over here to see what I do. So I look for the word down, and that tells me, so here's my ordered pair originally. So it looks like x stays the same, and then you take y and you minus whatever number is there. So x would stay the same for this one. And then the second one, x stays. I'm writing these in order because we might have to do 2 steps. And then you would take y minus 4. That's for the range. So because there were 2 moves, I listed what happens to the domain first, which would be this, and then what happens to it next, which would be that. All right, so now I'm going to have you try C as a checkpoint, just because we did 2 together, and you're going to use the chart. So I want you to pause the video and try C on your own. Okay, so looking at C, you would have had your parent function, or the function family was our f of x equals the square root of x. That's what the graph looks like, so we have it here. So this part, when we transformed it, we had to look at, remember we're going to use 0, 0. So what happened here is, if this was my 0, 0, I'm going to look, how did I get up here? So what happened is I went up 1. So it's that simple. I went up 1. So when you go up 1, you go to your chart, and we're looking at up this many, which means just on the outside of it, not in parentheses, we just put plus 1. So this would be f of x equals the square root of x and then plus 1, because it's by itself. So then now we're going to look at the domain and range. Since there was just 1 move, when we go up 1, we just need to look at what happens. So when I go up, it starts off with my ordered pair. So it says here my x stays the same, and then I add whatever the number is to the y. So this, because this stays, x stays, and then y plus whatever that number was. Well, this just happened to be 1. So that's what we're going to do to it. All right, now the last part, performing the translation of a given point. So we're going to use the given point of -2, 4, and we're going to do these moves. And this is where this comes in handy, this chart here. We're going to look for the words up, down, left, right, reflection, maybe stretch, compress. We'll just see what it says, and then we will follow this chart to see what we do. So the first one, it just says right 3 and up 2. So when I go right, what happens is I take x and I add how much I go right. So I do x plus 3 for the right 3. And then the up or down, I'm going to look for up or down. I do x stays the same, and then this is y plus whatever it is. So this is actually, I'm going to take y and add the 2. Because right, that's what happens. Right goes to something to my x, and it's always written in the way that you would be normally seeing it. We go right or left and then up or down. So we just take our x coordinates. So this becomes -2 plus 3, because that's our x. And then this becomes 4 plus 2, that's our y. And then we just put them in our calculator. 1, 6. And that's it. So the next one, again, we're going to just use our chart. If we go left, we know going left in our chart, when we go left, we take away from the x. So we do x minus whatever the number is, and y stays the same. So this means x minus 7. And then for up or down, something's going to happen to our y. So up or down, this one, it said up 1. So it means we are going to keep x the same and y. So we add y plus whatever that number is. So we have to do those 2 moves. So again, we're going to go back to this ordered pair. So -2 minus 7. And then our y is 4 plus 1. So I did those moves. So this becomes -9, 5. And then I want you to try C as a checkpoint. So quickly pause the video and see if you can get the answer for this. Okay, so hopefully for this last part, you got that you were going to subtract 2 from the x, and you were going to subtract 5 from the y, and then you would have had -4 -1. And I put this little chart here to kind of help you too, even though we have it on the other pages. But, you know, with the X, the domain, when we go left or right, if you go left, you subtract. If you go right, you add. Same with the range. If you go down, you subtract. If you go up, you add. So we are now going to go on to the 1.5 practice. If you need to rewatch this, feel free.